Welcome to Rise Up Namibia. So in this video, we're going to be looking at algebraic fractions involving addition and subtraction by Matt Yanata, aka the resistor of bad and the lover of good, hashtag dark and lovely _ walk by faith and not by sight. So example number 1, algebraic fractions. What do you do when you're told to simplify something like this? Now before we get into this example, I would like to make one thing clear. Before you attempt any algebraic fractions, I would advise you to at least know how to factor out common factors, factorize by grouping, quadratic trinomials, and difference between two squares. Now, if you're not familiar with these four, I would advise you to go check them out and come back to this video. So if you're not familiar with them, I'll put the links down below in the description that you can follow to each one of them. Okay, so if you're already familiar with this four, then you can continue with this video. Or if you're one of those risk takers where you're not familiar with this four but you feel like you want to continue with your video, feel free and enjoy the ride. So what do we do when we're told to simplify this? Now some people will see the 3x in the numerator and another 3x in the denominator and think of cancelling this two. But that's actually impossible because we have a plus sign here. Whenever you have a plus sign or a minus sign next to any term, that means you cannot cancel it out, okay? Unless if it's a multiplication sign. So if we had a multiplication sign here, we could cancel out this two. Good. So another rule would be that if you see that you have two terms, for example, in this numerator we have 3x and 6, which means there are two terms, always introduce brackets, okay? Now that you have introduced brackets, for those that are familiar with this four, when you introduce these brackets in the numerator, you can already see that we have a common factor of 3, okay? So what do? We factor out that common factor of 3 and we get 3 open bracket x plus 2 close bracket, and then the stays the same. Now because we have these brackets, this automatically becomes a multiplication, because brackets in other words means multiplication. So this is 3 multiplied by whatever is in the bracket, and this is 3x. So now because this 3 is multiplied with whatever is in the bracket, and we have another 3 here without any positive or negative sign next to it, we can actually cancel out this 3, okay? So we cancel out the 3. So what is left when we cancel out the 3? We have x plus 2 as a numerator, and we have a x that is left in the denominator. Now again, we can't cancel out this 2x because there's a positive sign next to it, unless it was a multiplication sign. Now when we look at this numerator and denominator, is there anything that we can factor out? Maybe by common factor, by grouping, or is there any quadratic trinomial or difference between two squares? No, there is none, which means that is your final answer. So you have just simplified this, okay? Let's look at another example. How about when you're told to simplify something like this? Now, coming back to this 4, okay, assuming that you know this 4, when someone that knows this 4 looks at these two, like the numerator and the denominator, one can already tell that both are quadratic trinomials, okay? So what do? You solve, or let me say you factorize the numerator separately and you factorize the denominator separately. So what do you get when you factorize these two? And mind you, if you don't know how to factorize by a quadratic trinomial, the link will be down below in the description. Okay? So when you factorize by like these quadratic trinomials, the numerator you'll get this, and the denominator you will get this. Good. Now when we look at brackets, like I said earlier, brackets means multiplication. So which means whatever is in this bracket is multiplied by whatever is in this bracket. Okay? The same with the denominators. Now we cannot just cancel this m with this m because there's like a minus and a plus next to them. But what we can do is, because the brackets means multiplication between the two, is that we can cancel out anything that is within the brackets that is the same, you know, in the numerator and in the denominator. Now from our numerator and denominator, is there any brackets that are the same? Yes, this m minus 2 is the same as this m minus 2, okay? Which means like one is in the numerator, one is in the denominator. So we can cancel out that because they are the same. Now what are we left with when we cancel out those two? We are left with m minus 3 and m plus 3. Now, when we look at this, can we cancel out this m and this m? No, we cannot cancel out those two m's. Why? Because we have one has a minus sign next to it, the other has a positive sign. And we can only cancel out if there is a multiplication, okay? Now, is there anything that we can factor out? No, there is no other number or term that we can factor out. So which means this is your final answer. Okay? Let's look at example number 3. How about when you are told to write as a single fraction, and they will mostly add in its simplest form. So what do you do when you're told to write something like this in its simplest form as a single fraction? So number 1, you have two fractions that you need to add. Okay? Now, if this is your first time adding fractions, I'll add another link down below in the description of a video that shows you how to add and subtract fractions. But if you're already familiar with adding and subtracting fractions, you can continue watching. So, what you need to do is, when you add two fractions, you can't just start adding them. You will need to make the denominators the same, okay? So this 9 and 6, you'll need to change it to be the same so that you can add your fractions. So how do we do this? We do this by using the LCM. What is LCM? It stands for lowest common multiple, okay? So let's start with the first fraction, which is 2m over 9. So when we look at the denominator 9, what are the multiples of 9? The multiples of 9 are 9, 18, 27, 36, and the list goes on. Okay? Let's look at the second fraction, the denominator 6. What are the multiples of 6? The multiples of 6 are 6, 12, 18, 24, and so goes the list on. Now when you look at these two lists of numbers, which number is the lowest common multiple, or which number is in both of them but the lowest? It's 18, okay? Because 18 is in this list of numbers and it's also in this list of numbers. So that 18 becomes our new denominator, okay? So now the denominators are the same. Now, before we run to conclusions that no, we are done with our denominators being the same, so we can just add the 2m and the 5m, there's actually something that you need to do, which is very important. Now, when you look at your multiples of 9, how many numbers did it take you to get to the LCM, which is 18? It took you 1, 2, okay? So you multiply 2 by the numerator, of the fraction which had 9 as a denominator. Okay, you do the same to the multiples of 6. You count how many numbers did it take you to get to 18. It took you 1, 2, 3. So you multiply that 3 with the numerator that was on top of denominator 6. Okay, so from here you multiply your 2 multiplied by 2m gives you 4m. 3 multiplied by 5m gives you 15m. Okay, remember the denominator now stays the same because they are both the same. Okay, so from here I just wrote it together because the denominator is the same, and I just put it over one denominator. So it's 4m plus 15m. What's the answer? It's basically 19m over 18, which is still our denominator, the same one. So just like that, you have found your final answer. Okay, so let's see, have you satisfied the what the question asked? Write as a single fraction. So yes, it is a single fraction, but sometimes they'll say, or most of the time they'll say, in its simplest form. So yes, this is its simplest form. Now some people use another method of just saying 2m multiplied by 6 and 9 multiplied by 6 and 5m multiplied by the 9 and 6 multiplied by the 9. If you know that method better, I'd advise you to use it, but it's just that when you use that method, you don't, sometimes, not in all cases, but sometimes you don't get to the answer in its simplest form. Okay, but if you grasp this method better, I'll advise you to use it as well. So let's take a look at example number 4. So here it says write as a single fraction. Let's just add in its simplest form. So now notice that we have an algebraic expression on top. Okay, and then our denominators are not the same as well. So what do we do? Like I said before, once you notice that you have two terms, like in this instance we have 2x plus 1, those are two terms, and x minus 1 is also two terms, always introduce brackets. Okay, so from introducing brackets, now we have two fractions, this fraction minus this fraction, and then we have to write it as a single fraction. Now before we can minus these two fractions, what do we need to do? We'll need to make the denominators the same. Now how do we make the denominators the same again? We make the denominators the same by using the LCM, which is the lowest common multiple. So what is the lowest common multiple of 2 and 3? These are the multiples of 2, which are 2, 4, 6, 8, 10, and the list goes on. And here are the multiples of 3. Now between these two lists of numbers, what is the lowest common multiple? It's 6, right? Now 6 being the lowest common multiple, it becomes our new denominator. Okay, so these are just the two fractions that I just rewrote. I just changed the denominator to 6. Now remember, before you rush to minusing again, always check how many numbers did it take you to get to the lowest common multiple in the multiples of 2. It took you 1, 2, 3. Okay, so you multiply 3 in the numerator of the denominator 2. Okay, so you go to the multiples of 3. You count how many numbers did it take you to get to the lowest common multiple. It took you 1, 2. Okay, so if it took you 2, you go to the fraction whereby the denominator was 3, which is the first fraction, and you multiply its numerator by 2. Why do we multiply this numerator by 2 again? Because it took us 1, 2 two numbers to get to the LCM of 6, okay, which is the 6. The same as the multiples of 2, just to like repeat this if you didn't get it. The multiples of 2, they are like, how many numbers does it take for you to get to the LCM? It takes you 1, 2, 3. So that's why you multiply its numerator by 3. Okay? So from here, you multiply your brackets out. So what's 2 times 2x? It's 4x. What's 2 multiplied by positive 1? It's positive 2. Okay? So that's our first fraction. And then you multiply out your second fraction. What's 3 multiplied by x? It's 3x. What's 3 multiplied by negative 1? Now, here is the tricky part. Always take note of this negative sign, okay? So, this is actually negative 3 multiplied by x. And then you get negative 3x, okay? And then negative 3 multiplied by negative 1 equals to positive 3, okay? So, remember now that you have already changed the denominators, they just stay the same, okay? So here I've just written whatever is on top together and then used the same denominator. So let's look for like terms. In our numerator we have 4x and negative 3x. Remember to take the signs with. And then positive 2 and positive 3 are also like terms, okay? So we write them down. 4x, and then what is 4x like term? It's negative 3x, so we write negative 3x next to it. And then we go to the next one, it's positive 2, so we write positive 2. And then what is positive 2's like term? It's positive 3, so we write the positive 3 next to it, okay? So we say 4x minus 3x equals to 1x. Now, as you all know, in algebra, when the answer is like 1x, we don't write the 1, but we just put the x. And then we have positive 2 plus 3. What's the answer? The answer would be positive 5, okay? So the denominator stays the same. Now from here, let's see if we have satisfied the question. The question asked us to write this as a single fraction, and right here we have it as a single fraction, okay, and it is in its simplest form. So this is our final answer. Let's take a look at example 5, algebraic fractions. Now here, take a look at our denominators. You know, now our denominators are like algebraic, okay? It's not just a number, and our numerators are numbers. Now don't panic, it's actually easy. What you do is, remember what I told you. When you see two terms, like for example, this is an x plus 3. These are two terms, and x squared minus 9. These are also two terms. What do? You introduce brackets, okay? So the question asked you to write as a single fraction. Let's just add in its simplest form, okay? Now, which means these are two fractions. First fraction, second fraction. And you're asked to write them as a single fraction. So what do? Now, looking at these two fractions, when you take a closer look at this denominator, you notice that it has a difference between two squares, okay? So x squared minus 9 is actually a difference between two squares. So what do? First of all, let's factor this out. So this is actually just the same as this, but in this case, we just factored this out, okay? So what do we do from here? So now I would like you to look at the denominators. So now, before we can subtract the two fractions, we are supposed to make the denominators the same. Now, how do we make the denominators the same? Or how do we see that these two denominators are actually not the same? Look. Okay, let me introduce this triangle to make it easier. This bracket, x plus 3. Let's represent it with this triangle. Now let's look at the other fraction. Is there an x plus 3? Yes. So let's represent it with a triangle as well. Now we have an extra bracket, which is x minus 3. Let's represent that bracket with a circle. Okay? Now to make these two denominators the same, because these are two fractions, remember? Now in this denominator, we have a triangle and a circle. While in the first fraction, the denominator, we only have a triangle. What does this mean? This means we need a circle. Okay? Or in other words, a x minus 3 in this denominator for them to be the same. So what do we do? So what I did here is rewrite this. It's just that I added space here. Now, what we do is to make these two the same. This circle that is not the side, we multiply both the numerator and the denominator by this bracket, which is the circle. So we bring it out like this. Remember the circle, this denominator that we didn't have on this fraction? Now we multiply both the numerator and the denominator by it. So what do we get? Okay, so the numerator, we can just multiply out like the bracket. So it is 1 times x and 1 times negative 3, which will actually just be the same. Now, but one thing I want you to notice is that when you multiplied this circle by which is in the second fraction, by both the numerator and the denominator of the first fraction, like what we did here, now when you look at your denominators, they are actually the same. Sorry, because now you have a plus or x plus 3 within one bracket and x minus 3 within the other bracket, which is also available in our second fraction. Okay, so because now we have found our lowest common multiple, or we have made the denominators the same, we can actually write whatever is on top. You know, when we multiply out this bracket, it will just still be x minus 3 because this is a 1. So we write that x minus 3 and then the minus 3, because now we can minus them because now the denominators are what? They are the same. So we write it as 1. Okay, we put it on top of the denominator, which is our lowest common multiple, and then we can minus. So now let's look for like terms. There's only one x, so x does not have a like term, but the negative 3 are like terms. These two negative 3's are like terms. So what do we do? So x doesn't have a like term, so we write it the same way it is, and then we minus like negative 3 minus 3 gives us a what? It gives us a negative 6. Remember the denominator here, because we made the denominator the same, the denominator stays the same. And please don't put the triangle and the circle in your final answer. That was just like for explaining purposes, to make it easier to understand. Okay? So this is your final answer. So let's see, did we satisfy the question, which was to write as a single fraction? Yes, because now we don't have two fractions anymore, we only have one fraction. Okay, so this is your final answer. Let's look at example number 6. So if you feel confident, I would like to to challenge you to pause the video and try out this algebraic expression and see if you'll get the right answer before I explain how to get the answer. So, okay. So here we have, in this numerator, we have two terms as well, which is m plus 2. And this denominator is another two terms, which is also m plus 2. Okay, so what do we do? Because there are two terms, we introduce brackets. Okay, now we have two fractions that we need to minus. Okay, this is fraction 1 and fraction 2, and we need to subtract them to get a single fraction. Okay, so I want us to look at one thing. So I'm going to introduce again this triangle and this circle just to explain something. Now in our first fraction we have a m, so we can represent that m with a triangle. Okay, now in our second fraction we have a bracket that consists of m plus 2. Now we can represent this whole bracket with a circle. Now before we can subtract these two fractions, the denominators need to be the same. Now how can we make these two denominators the same? We can only make them the same by having, let me say, in this first fraction, if we have a pyramid and a circle, and in the second fraction as well, by having a pyramid and a circle. So by now we only have one pyramid and one circle. So how do we get both denominators to be having both a pyramid and a circle? So this is what you do. So this is our first fraction, right? And this is our second fraction. So what you do is, because now the first fraction consists only of the triangle, which is m, and the second fraction consists of the circle, which is m plus 2, we multiply both the numerator and the denominator by the second fraction's denominator, which is the circle. So we multiply the numerator and the denominator by the circle, just like that. Okay, in our first fraction. Now we do the same to our second fraction, this side. We multiply the numerator and the denominator by the pyramid. Now what is this pyramid or this triangle? It's m. So we multiply it this side, okay? And now if you take a closer look, our first fraction has a denominator of m, open bracket, m plus 2, close bracket. And the second fraction also has the same denominator, although the m this time is like behind. But if you multiply them out, it will still give you the same answer, which is m, open bracket, m plus 2, close bracket. Okay, don't get confused. This denominator is the same as this one. Or in other words, we have one pyramid, one circle, one pyramid, one circle. Okay? So we multiply out these two brackets in the numerator, because now our denominators are the same. So let's get rid of any bracket that is on top. Okay? So what is m times m? It's m squared. What's m times 2? It gives you 2m. Okay? And then you go to the 2. What's 2 times m? It's 2m. What's 2 times 2? It's positive m. Okay? That was like our first fraction. Now mind you, because our denominator is the same, which is m, open bracket, m plus 2, we can just write it down like that. If you feel like multiplying it out, I believe you can also multiply it out, but you don't have to waste yourself or waste your time. Now when you look at the second fraction, when you multiply out the m multiplied by m, it gives you m squared. Okay? So now you look for like terms. When you check the m squared, it has another like term of m squared. Now these 2m and this 2m are also like terms. And then we have a positive 4 without without a like term. Okay? So what do you do? rewrite them in order to make it easier to like minus and add. So we say m squared minus m squared. Remember, when you look for the like terms, to take the like terms with their signs. So m squared minus m squared gives you what? Gives you 0. So which means this 2 cancels out. Okay? And then you get positive 2m plus positive 2m, which is here. And then positive 4 does not have a like term, so we just add it there. Now because the m squared minus m squared cancels out, we have positive 2m plus 2m. It gives us 4m. And then we have another, like the positive 4, which doesn't have a like term. We just bring it down the way it is. Okay? And then we also just bring the denominator the same way it is down here. And that is actually our final answer. Okay? So one would ask, why is it our final answer? Can you not cancel out this m maybe with this m? No, you can never do that. Why not? Because this 4m next to the 4m is a positive sign. I know and I understand this m and whatever is in the bracket, in between it is a multiplication sign. But what about next to the 4m? What sign is there? It's a positive sign. Okay? And maybe you were wondering, okay, this 4m and this 4 has a common factor of 4 and 2. Even though you factorize them or you factor out the common factor, it will still not be able to cancel out. Okay? So which means this is your final answer, which is like when you write it in a single fraction. So this is actually a single fraction that was asked in the question. Okay? So thank you very much for watching this video. Please do like, subscribe, turn on that notification button to be the first to see the next upload. Share with friends, family, and classmates. And remember, together we rise to higher heights. Apart, we all stay behind. Cheers.